Hi everyone. Notes 4.10 are on applications of quadratic equations, and this is the second day of these notes. And so let's take a look at our first example here. So it says that a hose is placed on an aerial ladder. The hose sprays water on a forest fire. The height in meters can be modeled by the relation H equals negative 2.25 times the quantity d minus 1 squared plus 9, where d is the horizontal distance in meters of the water from the nozzle of the hose. So before I do anything at all, I'm going to take a look and see what my one key feature is that I can just automatically identify. Because this is in vertex form, I can automatically identify that my vertex is going to occur at 1, 9. And I want to draw a sketch of what's going on here, okay? Just a really basic sketch. So it says here that the D is the horizontal distance right here. So I'm going to label this as horizontal distance. And then it tells us here that the height is measured in meters, and that's the h right here. So right here, we can say that this is the height. And I'm going to measure both of these in meters, okay? And let's draw a sketch of where our vertex is going to be. So we know that our vertex is going to occur at 1, 9, right? So we know that our vertex is going to occur right here. Let's also find out what our starting point is, or our y-intercept. So our y-intercept will happen when the horizontal distance is 0. So it's going to happen over here. So I'm going to replace this d right here with a 0. Let's go ahead and do that. So h equals negative 2.25 times 0 minus 1 squared, okay, plus 9. So here I get negative 2.25 times negative 1 squared plus 9. And then I get negative 2.25. Negative 1 squared is positive 1 plus 9. So then negative 2.25 times 1 is negative 2.25. Add 9 to it, and I end up getting 6.75. So this tells me here that at 6.75, I'm going to start the water is coming out from an initial height of 6.75. So we know that this graph is going to increase and then decrease because this is a negative a value, so that means it opens down. So it's going to look something like this. I don't know exactly where it hits the ground. I could calculate it if I need to, but this is a good enough sketch for me to see what the questions are asking of me. And then if it asks me when does it hit the ground, then we could figure that out, okay? So question A says, what is the maximum height reached by the water? So if I take a look at this right here, the maximum height that the water reaches is 9. So we're going to say 9 meters. Then it says at what horizontal distance from the nozzle is the maximum height reached? So where does it cross horizontally? So we know that the horizontal distance right here is going to be 1. So this has gone over by 1 as it reaches its highest point. So here the answer is 1 meter. Okay, and then lastly it asks, next is what is the height of the aerial ladder? So this right here is where the ladder is, right here. And the water is shooting out from right here. So the height of the aerial ladder is 6.75 meters. Okay, and then lastly, it says how high is the water when it is at a horizontal distance of 2 from the nozzle? So there's two different ways we can figure this out. The first way is if I take a look right here, I can just replace the horizontal distance, the d value right here with a 2. Horizontal distance, d would be 2. So let's go ahead and take a look at what that would look like. So here I would say h equals negative 2.25 times 2 minus 1 squared plus 9. So here I'll put a 2 in. And then 2 minus 1 is 1. And then 1 squared is also 1. And then negative 2.25 times 1 is negative 2.25. Add the 9 to it, and you end up getting 6.75 meters. And if you notice, we've seen the number 6.75 before because that's where the y-intercept is. And this right here, the axis of symmetry, is 1 away from the y-axis. So that means that at 2, right here, it's also 1 away, and so it has to reach that height of 6.75 at the same time because it's our symmetrical point. Okay, and that's it for this question. All right, and number 2, it says, while standing on top of a building, Claire threw a ball in the air. The height of the ball, h, in meters is represented by the equation that's given right here, where t represents the time in seconds. So here's our equation, and if you notice, this equation right here is written in standard form. So question A says, algebraically determine the key features to draw a graph of this scenario. So just a reminder that our 4 key features are the roots, the axis of symmetry, the vertex, and the y-intercept. So let's do the roots first because that's the hardest one. That'll take the most time. So let's just get that out of the way. So to find the roots, I could either try to factor, complete the square, or do the quadratic formula. Because these values are decimals, the idea of factoring is not that alluring to me right here. So instead, I'm going to use the quadratic formula. And you know how normally it starts with x equals negative b, but here the x is like t, so I'm going to say t equals negative b plus or minus the square root of b squared minus 4ac all over 2a. We know that a is negative 4.9. We know that b is 9. So this is the a right here. We know that b is 19.6. And we know that c is 18. So here, when I plug in all that information, I end up getting negative 19.6 plus or minus, I'm just going to zoom in a little bit right here, the square root of b squared, which is also 19.6, minus 4 times a, which is negative 4.9, times c, which is 18. And that's all going to be all over 2 times a, which is negative 4.9. Okay? So right here I get negative 19.6 plus or minus the square root of, I'm going to type this all into my calculator and see what I get. So I'm going to type in 19.6 squared minus 4 times negative 4.9 times 18, and I end up getting 736.96. And that's all over 2 times negative 4.9, which is negative 9.8. Now I'm just going to get my two answers by plugging this into my calculator. Notice how I have not actually typed this into my calculator. I'm going to type the whole entire fraction into my calculator. So using Desmos, if I press the division key, I get my fraction right here. So I'm going to type in right here negative 19.6 plus the square root of 736.96 all over 2 times negative 4.9, which is negative 9.8. And here I get negative 0.77. Okay, so I'll write that down. Here I can say t is approximately negative 0.77, and then let's go ahead and calculate the other answer. And the nice thing about Desmos is I can actually just go up here and then just delete this plus sign, change it to a minus sign, and then I get my other answer, which is 4.77. So that tells us that for our key features, our first key feature, our roots are going to be negative 0.77 and 4.77. Okay, now we want to find the axis of symmetry. So let's go ahead and do that. We've got two options to find the axis of symmetry. Our first option is to just average our roots. So I could take negative 0.77, add 4.77 to that, and then divide that by 2. So here I would get 4 over 2, which is 2. Okay, or I have another option of using the formula x equals negative b over 2a. And here we know that the b is 19.6. So I would say negative 19.6 over 2 times a, which is negative 4.9. So then I get negative 19.6 over negative 9.8, which is also 2. So we know that our axis of symmetry is equal to 2. Okay? Now let's go ahead and find our vertex. So to find our vertex right here, I'm going to say that if I know that x equals 2, and I apologize people, I should not have used x. I should have used t because this right here is using t in our equation. So to find our vertex, we know it's going to happen when t equals 2. So I'm going to write out my equation. H equals negative 4.9 times t squared plus 19.6 times t, which is 2, plus 18. So I'm going to fill in 2 in for each one of these values. And I'm going to go straight to Desmos, and I'm just going to type it in exactly how I see it because I don't want to be bogged down by all the calculations. So negative 4.9 times, don't forget to put your number that's being squared in brackets. It doesn't matter if it's a positive, but it does matter if it's a negative. Plus 19.6 times 2 plus 18, and we end up getting 37.6 here. So here we know h is 37.6, which means that our vertex is going to be 37.6. And then lastly, we need to find our y-intercept. And our y-intercept, just a reminder, we've got two options. We could either plug in 0 for t. So this time, every time I see a t, I'm going to plug in 0. But we know this gives us 0 and this gives us 0, so we would get 18. Our other option is just to say that it is always going to be the c value, always, right? So here, our y-intercept is going to be 0, 18. All right, so let's graph out this information here. We have enough information to graph this out. Now, one quick note about this is that when we're talking about what is going to be labeled here, we know that on the x-axis, this is going to be time, and this time is measured in seconds, it tells us right here. And we know on the y-axis, we are going to have the height. And the height is measured in meters right here, okay? But one thing I want you to realize is because we're talking about time and height, both of those values are going to be positive values. So we are only going to look at positive values for x and positive values for y, okay? So here, for time in seconds, I know it's going to need to go to at least 4.77 seconds. That's the root. That's where it crosses the x-axis. After that, I don't really have a graph. So I'm going to go out to about 5. So if I go by, if every fourth value I have here is a whole second, then I have enough space to do 5. And then I also know that the highest point that my graph is going to reach is 37.6. So I'm going to space out my height in a way so I can get to 37.6. There are 20 blocks, so I'm just going to say that every block is 2. So this would be 2, 4, 6, 8, 10. Then I've got 12, 14, 16, 18, 20, so on and so forth. Here we've got 30, and then here we've got 40. And now I can go ahead and label in the information that's given to me. First of all, my first root is a negative 0.77, but I can't have a negative time. So I'm not going to graph that point out. But my other root is 4.77. So I'm going to go on my x-axis. I'm going to go to 4.77, which is pretty close to 4.75. This is 3/4, which is 0.75. So I know it's going to be there. Okay. The next thing I want to graph out is my axis of symmetry. And we know that's going to happen when time is 2. So I'm going to graph out a vertical line right at 2. Okay. The next thing I want to do is graph out. So I'm just going to put checks here. We did our roots. We did our axis of symmetry. Now we need to do our vertex. So this is going to happen at 2 seconds and 37.6 meters. So this right here is our highest point right here. And then lastly, we have our y-intercept, which is going to occur at 0.18. So here's where my y-intercept is. But I'd like to do the symmetrical points on the other side of my y-intercept. So because this is 2 away right here, this is going to also be 2 away. So that means that at 4 seconds, I'm also going to have a height of 18. And then I can just connect the dots, and this is my graph right here. Okay, so now that I've done that, I can go ahead and answer some of these questions. So question B says, from what initial height was the ball thrown? And the answer to that question is right here. It was initially thrown from a height of 18 meters. All right, question C says, determine the maximum height the ball reaches. So the first part is determine the maximum height the ball reaches, which we know it will reach a maximum height right here of 37.6. We have that number right here. And then it says, how long does it take to reach that height? So we can look and see that it took 2 seconds to reach that height. So we'll say at 2 seconds. All right. And then part D says, how long will it take the ball to reach the ground? Well, we know that this right here is where the ball will reach the ground. And we know that that answer is 4.77 seconds. And then lastly, it says Claire's friend, Charlie, is standing on the ground and needs to avoid getting hit by the ball. Determine how long it will take for the ball to reach Claire's friend if Charlie's head is 1.7 meters above the ground. So we want to know, when will this ball reach a height of about 1.7 meters above the ground? So we know that it should be close to 4.77 seconds, but we have to actually figure this out. How do we figure this out? Well, we use our equation. H equals negative 4.9 t squared plus 19.6t plus 18. But this time what we're given is a height of 1.7 meters. So I'm going to replace the h with 1.7, and then I'm going to copy the rest of this equation down. But in order for me to be able to solve this, I need to move everything over to one side. So I end up getting 0 equals negative 4.9 t squared plus 19.6 t plus 16.3. Or if you wanted to, you could have moved everything else over so that way you wouldn't have had a negative. It's totally up to you, a negative leading coefficient. But now I have a quadratic equation that I can solve by either completing the square, quadratic formula, or factoring. I don't really want to factor it because if I factor it, I would end up having to deal with decimals, and I just don't feel like dealing with decimals. So here I'm going to identify the a value, the b value, and the c value. So the a is negative 4.9, the b is 19.6, and the c is 16.3. So here I'm going to do x equals, or t equals negative b, plus or minus the square root of b squared, which is 19.6, minus 4 times a, which is negative 4.9, times c, which is 16.3, and that's all over 2 times a, which is negative 4.9. So here I end up getting, I'm just going to put a line down the middle right here, 19.6 plus or minus the square root of, let's figure out what this is as a number here. So I'll type in 19.6 squared minus 4 times negative 4.9 times 16.3, and I end up getting 703.64. And that's all over 2 times negative 4.9, which is negative 9.8. I'm going to go ahead and type both of these into my calculator to get my two approximate answers. So my first one, I'm still going to need a fraction in here, so I'm going to do my division sign. Negative 19.6 plus the square root of 703.64 all over negative 9.8, and I end up getting negative 0.71. And then on the other side, I'm going to change this this plus sign into a minus sign, and I get 4.71. So here, t is 4.71 seconds, which should make sense because it hit the ground at 4.77 seconds right here, and 1.7 is pretty close to the ground. So therefore, it will take 4.71 seconds to reach Charlie's head. And that's it for this question. Okay, and number 3, it talks about the profits from selling tickets. So let's read through the question, and I'm going to underline or highlight key information. So the profits from selling tickets for concerts are dependent on the price. A band that is going on tour has found out that they will break even, which means their profit will be 0, if they sell tickets for $20, and that they will get the most profit, most meaning highest amount. So flags should go off in your head saying Vertex, because this is the highest amount, if they sell tickets for $36. Okay, and then it says find an equation that models the relationship between the band's profit and the cost of a ticket. So let's draw a sketch of what's going on here. So we know that we're comparing the profit to the price of a ticket, okay? So right here, the profit is based on the cost of a ticket. So the cost is the independent variable, and then the profit is the dependent variable, okay? And we know that if they sell a ticket for $20, so I'm just going to put 20 right here, that they will break even. So $20 means that they will break even right here. We also know that if they sell a ticket for $36, they will reach their maximum profit of 7,360. So I'm going to put 7,360 right here. We know that that will occur at $36. So this means right here that my graph is going to increase, increase, increase. And then at this point right here, it's going to start to decrease, decrease, decrease. And hopefully you should realize that this value right here occurs at a symmetrical distance right here. So this right here has a distance of 16. This also has a distance of 16. So this value right here will occur at 52, which means that I've got a bunch of key features. I've got two different routes, and I also have my vertex right here. So now, because the first question was in vertex form, the second question was in standard form, I want to find the equation of this in factored form. I have the root, so I can use factored form. So factored form is y equals a times x minus r times x minus s. However, instead of y, we're going to use p. And instead of x, we're going to use t for the cost of a ticket. Okay, and we know that our two roots are at 20 and at 52. So here I'm going to say P equals A times T minus 20 times T minus 52. Okay, and then in order to solve for A, I have to plug in a point, and the point that I'm going to plug in is 36, 7,360. So let's go ahead and do that right here. So this right here would be 7,360. That's going to be equal to A times right here, the t value that I'm going to plug in is going to be 36. So I end up getting 7,360 is equal to A times 36 minus 20 is 16. And then 36 minus 52 is negative 16. I'm going to just bring this up here. So 16 times negative 16 is negative 256. Divide both sides by negative 256. And I end up getting negative 28.75. So that means that my equation in factored form would be P equals negative 28.75 times T minus 20 times T minus 52. In complete honesty, we can also write out what our equation is in vertex form because we know the vertex and we know the A value. It's not going to change. The A value is going to stay exactly the same. So we can also say in vertex form, it would be negative 28.75 times T minus 36 squared. Let me just move this over for some more space, plus 7,360. Okay? So then part B says determine the profit from a ticket with a price of $50. I can use either equation and I would get the same answer. For this one, I'm going to use the factored form. If you want to use the vertex form and see if you get the same equation as me, go for it. This time we know that T, this is telling us here that T is equal to 50. So I'm going to replace the T with a 50. Every time I see a T, I'm going to replace it with 50. So here I end up getting P equals negative 28.75 times 50 minus 20 is 30, and then 50 minus 52 is negative 2. And then I'm just going to type that all into my calculator. So negative 28.75 times 30 times negative 2 gives me 1,725. And if you were to use the vertex form, it would give you the exact same answer. So therefore, the band have a profit of 1,725 for a price, for a ticket price of $50. Okay? And then part C, in order for the tour to be worth it to the band, they want to make it at least $6,500. What range of ticket prices can the band have to make this profit? So right here, I'm going to use my equation, but this time I'm going to use the vertex form just to switch it up a little bit. And I want the profit to be at least $6,500. So in order to be able to solve this, I need to move this 73,000 7,360 over to the left side. So I'm going to subtract this, and I get negative 860. And that's equal to negative 28.75 times t minus 36 squared. Now I want to divide by negative 28.75. Now look right here. When I divide this number by negative 28.75, I end up getting a decimal, which I don't want. So right here, I don't want to deal with a decimal quite yet. So I'm just going to say that it's negative 860 over negative 28.75. And that's t minus 36 squared. But here's the thing, the double negatives turn into a positive. So I'm going to leave it as a positive, okay? So then in order to solve this, I have to square root both sides. So I get the square root of 860 over 28.75 is equal to t minus 36, but do not forget your plus or minus. Now just move the 36 over, so you get 36 plus or minus the square root of 860 over 28.75. That's what t would be. So now I want to figure out what my two different t values are. So I'm going to go straight to my calculator and type these values in. So my first value is going to be 36 plus the square root of, I'm going to insert a fraction in here, and I'm going to type in 860 over 28.75. And because we're talking about money, I'm going to round to the nearest cent. So this is $41.47. But I also need the subtraction version. I need this to have a minus sign here. So I'm going to delete the plus sign, change it to a minus sign, and I get $30.53. So, and both of these answers will work. Let me show you visually why both of these answers will work. So I want to know when they want to have a profit of 6,500 minimum. So that means that we want this to have a profit of 6,500. So we've got one value where it will work, which is the $30.53 that we got here. And then we have another value that will work, which is the, I don't remember, $41.47. So here we can say, therefore, in order to have a profit of at least 6,500, they should sell tickets for $30.53. And I'm going to add in here anywhere between $30.53 and $41.47. And that's it for this video. Let me know if you have any questions. Otherwise, I'll just see you in class. Have a great day. Bye.